Hello everyone. In this video, let's discuss about the ununiform search technique. The first one will be DFS. So what is DFS? DFS is the depth first search algorithm. Depth first search algorithm. So this topic of the depth first search algorithm will also come in the data structures and algorithm and in artificial intelligence and machine learning also. Let's discuss. Now this ununiform search technique will not have the domain specific knowledge. That means this A router or A node will be having the knowledge of B and C only. It will be having knowledge of B and C. It will not be having the knowledge of D, E, F, G node like that. So ununiform search technique not have the domain specific knowledge. Now if we look at the properties of the depth first search algorithm, it uses the LIFO, that is stack data structure, and it uses LIFO. What is LIFO? LIFO means last in first out. Last in first out. Who will come into the stack at the last, they will be kicked out from the stack first, like that. So let's solve the problem, you will get to know how. Next, it will not give the optimal solution or cost. Optimal cost or solution is not given. And it is called as incomplete because I will tell when we solve the problem. Now type complexity also let's discuss at the later stage of this question. Now if we consider this tree or the graph, let me consider A as the root node or the router, main router. So since only one element is there at this level, so this will be called a level 0, level 1, level 2. So only one element is there and I will put it into the stack and I will write my result right here. Only one element is there. I said who will be put at the last, they will be kicked out from the stack at the first. Last in, first out. Only one element is there, that will be removed from the stack and will be written at the result. Next, from A, where we can go? From A we can go to B, and from A we can go to C. So we must write the new one, new stack, because A is removed from the stack. So it can go to B or it can go to C. So you can write B first or C first. Now among B and C, who is in the top of the table? That is last in. So B came first and C came last. Last in, first out. So we will be removing C and writing C here at the result. Now if you see the C router or the C node, it is going to F and it is going to G. Now let's write the new stack. So B will be as it is. Instead of C, it is going to F and it can go to G. Now who came at the last? G came at the last. So we will be removing it and we will be writing it in the result. So if you see G is the leaf node. Leaf node means it is not having any more child. So we will stop the process there at the G. Now which is at the last? That is who had came last? F is there and B is there. So F is the last one to come. So it will be kicked out from the stack first. So F will be written. So if I see F node, so F is also having 0 child node. That is it is not having any child. So only B is left in my stack. Now I will kick out B because only one element is there. So if I kick out B, B can go to D and it can go to E. It can go to D and it can go to E. You can write E first then D, like that also. Now E is the last one to enter. So it will be kicked out first. And E is the leaf node which is having 0 child node. So only D element is left. So since only one element is there, it will be removed from the stack and the row and will be wrote in the result. So this is one possible way. So another possible way also we can write. So first A will be there. Here I wrote first B and then C. So last was C, I removed first C because last in, first out. So another possible is B will come first. Now in this condition, if I took B first, because we could have taken B or C, In this part we took C as first, so C came here because it was the last to come in, so we wrote the result as C. Now if C was coming here at this place and B at this place, then B was the last to enter, so it will be removed first. If B was removed first, so B's two childs are D and E, so it can go to D and it can go to E. Another possible is A to B and it can go to E first and then come to D first, D later. Now so AB, DE is over, next it can come to C. So if it come to C node, it can go to F and G, or it can go to G and F. If you see, many possible results are coming. So since many possible results are coming, it will be called as the incomplete because we are not having the definite answer for it. And if you see the time complexity of the depth first search algorithm, so this is of the order of V plus E is of data structures and algorithm perspective. So V means vertices and E means edges. And in the perspective of artificial intelligence and machine learning, it will be order of B power D. B means the branching factor and D means the depth. Hope you understood the concept of depth first search algorithm. If you like the video, please subscribe for more engineering related topics, and the video playlist links of all the artificial intelligence and machine learning concepts are given in the description. You can access them. Thank you.